However, after 30 years, science and technology had changed considerably. The main purpose of Kulik's trip had been to locate huge meteoritic masses, but now the purpose was to find very small particles of cosmic dust. Magnetic methods were used to collect sample material. All samples were sent to the camp, which was again based on the river Kushmo. In samples taken from the central portion of the uprooted area, metallic and silicate spherules were found. The spherules were subjected to investigation in a field laboratory, and the chemical elements normally present in cosmic substances were found in these spherules. It was noted that the number of spherules in the soil increased with distance from the center of the area. With these findings, it became necessary to increase the area of investigation. Sampling procedures employed while moving through these remote areas required ingenuity. The expedition carefully documented all areas where the forest was destroyed, more precisely determining the boundaries of the area where the forest had been uprooted. Land contours were measured, as was the direction of uprooting of the trees. As a result of this investigation, the first schematic chart of the uprooted forest was prepared based on a thorough topographic study. The chart was completed in 1961 with a detailed description of the taiga. The area covered 2,000 square kilometers. The expedition in 1961 was the most productive of all the expeditions to the Tunguska area. It comprised a large group of scientists of various disciplines. An independent biological expedition had joined the fieldwork in 1960. At that time, 120 stations were set up, which served as the basis for detailed studies of the direction of the uprooting. The director of this group was an engineer by the name of Plekhanov. His group also noted the rapid growth of trees following the year 1908 and the nature of their scorching. There was a general notion among the people that the Tunguska meteorite must have been the result of a nuclear explosion of a spaceship. However, the enthusiastic young investigators corrected this notion. They cut down trees and investigated the rings, tracing them to the year 1908. The ash was then subjected to radiochemical investigations, and no traces of radioactivity were found. At the same time, another group was conducting an investigation in the area of the swamps. The magnometric method was employed, as during the earlier investigation of Sikhote-Alin. However, conditions under which they were to work were frequently much more difficult. Masses of magnetic material could not be found on the bottom of the swamps, and specialists came to the conclusion that the depressions in the swamp and the layers of peat were of terrestrial origin and had no connection with the fall of the meteorite. It soon became evident that the cosmic body had exploded in the air and did not reach the Earth. This lake, which is sometimes called Swan Lake, is the largest body of water in the vicinity of the fall. From the sediments of such a lake, similarly as with the rings of a tree, one can study yearly deposits. Now, with greater effort, the search for meteoritic material continued. The scientists were able to establish the aerial distribution of the concentration of magnetic spherules. It led in a northwesterly direction and was explored for a distance of 400 miles. In 1962, the work of the expedition was transferred to the banks of the river Chunya. Samples from the bottom of the lake were also studied. From various points, samples were delivered by helicopters to the base camps. The initial investigation was performed in a field laboratory. However, the basic work was performed in Moscow in the Vernadsky Institute of Geochemistry and Analytical Chemistry. Various instruments were employed to separate the magnetic portion from the bulk sample. And the sample was separated into size fractions. The magnetic drum collects the magnetic portions from the bulk sample. From this vibrating flat surface, the scientifically important spherules were obtained. Spherules 1/100th of a millimeter in size were subjected to special chemical analyses. For this type of analysis, unique techniques were employed. This balance can be used for weighing 1/1000th of a gram. Micromanipulators place the spherule into a container of minute diameter. A sample is obtained by use of a centrifuge. The separated density fraction can only be worked with under a microscope. X-ray spectroscopic investigations were also conducted, along with the microchemical work. This method allows the study of chemical composition of various points within a dust particle. The analysis indicated that nickel was not distributed evenly within the spherules. Its composition varied distinctly from the center to the outside of the spherule. What was the cause of such a significant difference in the distribution of the nickel? Could it be connected with the origin of the spherules? An experiment was performed in an attempt to find the answers. Minerals characteristic of cosmic bodies were investigated in Florensky's laboratory. Tiny grains were melted, gases evolved, and complex chemical processes took place. Finally, artificial spherules were obtained.